How's it going, everybody? And today, I wanted to make us something interesting today. If you are already familiar with my content, you know I am an anarchist and an atheist, right? But because as an atheist, I hold a philosophical position of naturalism, ontologically a naturalism, and to be more specific, physicalism, where pretty much most scientists, especially physicists, come to the consensus that everything is reduced to the physical, and quantum mechanics is basically the fundamental part of reality, right? Everything reduced in the quantum realm because that's basically the fundamental aspect of it, right? Now, thanks to the new Nobel Prize of Physics, everything turns upside down because for the longest time we thought that the philosophical position on quantum mechanics is local realism, which was a position proposed and basically dominated for the past 70 odd years with the by Albert Einstein established that he to make it summarize the basic if this is how classical mechanics, right, the planets started, like Isaac Newton pioneers, if this is how it behaves, well, it will make sense if quantum mechanics behaves the same. And basically, that's what local realism is. Now we know this is false. Not only Einstein was wrong, he was demonstrably wrong. So now we know two things. That basically, if I can't remember the term, forgive me if I completely wrong which of the two terms were, that either symmetry or asymmetry, it's either one of the two, I just can't remember right now, it's wrong. They do not technically exist. And the universe, the reality doesn't function on the local realism. In fact, it functions non-locally. While most of the Nobel Prize focus more of the practical aspects like quantum entanglement, how we can actually use a quantum internet and teleportation and stuff like that. Which technologically speaking, that will pioneer so much. In fact, how we can use AI with quantum mechanics and how we can observe things like the brain or the human body and stuff like that in a more efficient manner. Maybe learn new things about it that for the longest time classical computers cannot do, or at least cannot do to the extent that we desire to have, right? But this is the interesting problem. Now we know that local realism is false, and the universe, fundamentally speaking, functions under non-local. Now we have to reconsider every single theory, right? Scientific theory, and even who were not scientific but they want to use the same principles, right? That were considered pseudoscience or religious nonsense, right? We have to reconsider now because now we know that the universe functions non-locally. Every other scientific theory before the 2022 prize came in that we were critical, if not we outright reject as considered pseudoscience, now we have to reconsider because now we know non-local is true. So how does this mean? Well, it affects basically a lot. In fact, one of the biggest challenges we saw recently is the consciousness. For the longest time, and technically we still do hold this view that the idea of quantum consciousness is pseudoscience. Mainly because two things. One, most people who were proponents of it were religious people who had no understanding how science works. But because these people were the people who primarily promote these ideas, people had the assumption that consciousness and quantum mechanics has nothing to do with science, even though there is a legitimate scholarship about what how much quantum mechanics is actually involved in consciousness. But I would recommend a video in the description by PBS who actually talks about the actual scientific process and implications of it, and not talk about if I meditate I can manipulate reality if I think hard enough or something like that. No, that's not how it works. And two, the actual science behind this study is different. But regardless, because of this, it gets an interesting reevaluation of what it is and what is not true in these cases. For example, in April, they made an experiment about of the idea of quantum mechanics using anesthetics that alters behavior, tiny structures of the brain cells, which they will bring the idea, which was considered fringe if not straight up pseudoscience, may have now some possibility. The article by the New Scientist, by the journalist Thomas Luton, who reported this, right? This was published months and months before the Nobel Prize. So at the time, people still were under the assumption of local realism. And remember, the idea of quantum consciousness of any kind was under the assumption of non-local. And now we know non-local is how the universe actually works. We have to reconsider. From the article, quantum experiments add weight to the fringe theory of consciousness. Experiments on how anesthetics alter the behavior of tiny structure found in brain cells bolster controversial idea that quantum effects in the brain might explain consciousness. The controversial idea has passed a key test. Experiments show that anesthetic drugs reduce how long tiny structures found in brain cells can sustain suspected quantum excitations. And anesthetic switch consciousness on and off. The result may implicate these structures called microtubules as the next set of our conscious experiments. Like I said, you can read the entire article in New Scientist, right? But for now, because now we know that the universe functions non-locally, these previous criticized, if not considered pseudoscience, now have to be reevaluated because they were holding a position that now we know technically is true. But now we need to find evidence if specific theories were they proposed earlier were true, or if they were true, how much to the extent. And one of my favorite popular science publishers, Shan, who I think is best known for his promotion of the many words interpretation, even though most scientists do not agree with it. Well, there is no consensus per se about the interpretation of quantum mechanics. The most people, like statistically speaking, support the Copenhagen interpretation, and the many words interpretation, although it's the second most popular option among physicists. The problem with the many words interpretation that even if it's true, the problem with the idea is more like the person who came up with it, Everett, was like, hey, it would be cool if this happened. It wasn't an actual scientific theory. It's more like a would it be cool what if scenario. And but Shan, despite a great writer, right, who focused more on physics, like the philosophy of time and like symmetry, and now we know, like I said, I can't remember it's either symmetry or asymmetry. It's turned out to be not true anymore, so he there's gotta be updates to the literature now. But Shan, when he wrote The Big Picture, like an introduction to poetic naturalism, which is not a new form of naturalism, it's just physicalism but mixed with secular humanism. That's about it. It's one of my favorite comments I saw people talk about Shan, who were like, despite how great it is, like he contradicts himself a lot. And when it comes to specific areas in philosophy, like for example, there's a paper that he wrote on physics and consciousness. On the one hand, it's a great argument against all forms of dualism beyond a phenomenalism, which is the only form that has some legitimacy, philosophically speaking, among experts, right? And maybe scientifically, but for now, we cannot say that for sure. While acknowledging the reality of subject experience and limits of modern physics, he lays out a really grounded reason not to expect anything physical are going on inside the brain. But like I see people say, the brain is a radio. But no, stop. We have actively falsified the idea. Dead end of story. He puts that kind of thing in clear and polite terms. But then, he says science will likely reveal that consciousness is weakly emerged. But when discussed the only weakly emerged explanation of consciousness, like panpsychism or neutromonism, he rather be accused of disturbing physical ontology when avoiding that is the whole point of panpsychism. Like seriously, how is subjective experience going to weakly emerge from objective observation? Like he is a great thinker, And he actually realized the contradiction he did. He accidentally promoted something that he himself didn't subscribe to. So he just became a limited materialism, which most neuroscientists and cognitive psychologists don't even subscribe to anyway. The majority are either reductive physicalists, to be more specific, functionalism and computational theory of the mind. I recommend the book The History of Philosophy by A.C. Grayley. There he talks about the consensus among people study the brain and consciousness, like you know. But like I said, it's kind of funny. This is an interesting thing we have to reevaluate, right? As a naturalist, right? We have to reevaluate. Now we know that non-local is real, right? This will affect all the other previous positions that assume the universe is non-local. We criticize, we consider pseudoscience. Now we know that non-local universe is the correct view. We have to reevaluate a lot. One of the more popular examples recently in like scientific literature is the how do I describe this theory? The relational quantum mechanics. It's an interpretation of quantum mechanics, first proposed by Carlo Rovelli, and because his ideas of quantum mechanics, right, rely because the universe is not local. The outspoken thought behind the intrinsic property, or essentially quantum mechanics property, as well as some research, links the relate the links the relation of quantum mechanics interpretation to quantum consciousness as well. And because they assume not only is a subjective interaction between the observer and the physical system, which again there's gonna be a lot of implication for the next couple of decades, and because now we know that the universe, Einstein's view of the reality is false, right? This local realism, right? How now we know this. Now we know that it's non-local, and there's this great paper by the the medical library. If the how do I pronounce that it correctly? It's basically the National Library of Medicine of the United States, which is the biggest medical library in the world. They made a paper 2 years before the Nobel Prize happened, before to confirm the local non-local debate thing. It's written by Andrew Lorraine and Bruce Bergman, called The Non-Local Universe. In the abstraction, they say, we propose that the universe is non-local. The appropriate worldview paradigm for this understanding is non-local realism. Currently, the worldview of local realism guides the frame the understanding and interpretation of science. Local realism was the worldview employed by Einstein's relativity theory, but the principle of this paradigm had operated as the guiding framework for the rest of classical science for more than a century. This paper points to the incoherence in local realism and to the violation of its principle by recent experiments. It suggests that these negative effects had undermined the credibility of the legitimacy of this worldview. We are more inclusive worldview for future science called non-local realism. A worldview of non-local realism encompasses meaning, mind, and universal consciousness. The introduction, a paradigm or worldview is not a theory or a series of theories or a hypothesis, like Thomas Kuhn saw in the imperfecto imperative. And now, we consider the future science rests on changing psychological reference from local realism to non-local realism. It's a term we use to represent a holistic and integrated worldview that displays the reality, hence realism, on a singular, integrated, interconnected universal field of relationship. And also now we know that in physics, everything is basically semi-digital as well, which is another interesting aspect to understand. This paper was released like in 2016, 2017, give or take. So yeah, the reality of this paradigm is established by the evidence that the universe we perceive, measure is non-local by analysis of integrated nature of the meaning we make. Non-local realism is closely related to the views exposed by Erwin Scrivener that the overall number of minds within the universe is just one. We went further by suggesting that mind has erected the physical outside world out of its own mental stuff. The interconnected universal consciousness implied that the concept of one mind constitutes the non-local, singular implicitly reality of a universal consciousness that had embedded within itself the local and explicit conscious mind of each individual. The paradigm of non-local realism denies the absolute dualism inherent within local realism, along the specific separation of mind and the more general psychological tendency to divide and separate all aspects of the world. As a consequence of this emphasis, the primary status that had traditionally been given to independent physical world disappeared. Yet the disappearance of this primary status does not make the physical world disappear. The withdrawal of this status comes from the reconstitution as the secondary effect produced by local minds through the process of perception and conception. As Laurent argued, this relocation of status comes about because the context of universal consciousness is taken into account as the fundamental context, a context which local minds, which perception and conception of the physical world have a secondary status. The reallocation of the physical world status comes about because the asymmetrical structure of universal consciousness, which stands as the pyramid background context of which all of science is right. Universal consciousness has a structural order in which hidden implicit meaning always has primacy over the secondary status, the explicitly meaning of distinction and difference, and these always involve the objects and forms. This order tells us that the fragments, parts, options, and form always arise from a whole, not the reverse, and also the explicit meaning always arises from implicit meaning, and the humans always rise from nature. This asymmetrical order enforcement that consciousness has a local mind and a physical body, rather than the reverse that says the body has a local mind that is conscious. However, while individual human minds have a secondary status within the paradigm of non-local realism, they are always the ground which all interpretation and observation are developed. Unlike local realism, which ignores or sidelights the human mind or treats it as an entity, the non-local realism as a core, the human mind is a context for all meaning-making psychological activity. This means that the observer is never simply a local subjectivity, but represents the local entrance into a broader implicit context of non-local implicit universal consciousness. The status of the observer as context becomes more obvious when we get to take seriously the idea that the only way that we're able to know the physical world, and that includes the brain that neuroscientists study, is by observation and conceptualization, and both of these psychological processes operate within the mind of the observer. This critical evidence tends to dismiss or devaluate by local realists. Hence, any scientific interpretation that is framed by that paradigm of non-local realism would take on a different character for those seeing the lens of local realism. Hence, the difference would be replacing gaps, division, separation, which integrates sense and inclusion and interiority. For example, all relationals, both local and non-local, are internal to the singularity of universal consciousness and operate entirely within this domain, with no relations existing or functioning outside of it. This universal domain of consciousness is not the same as the domain of subjectivity, in terms implicate to dualism of local realism. Thus, the subject does not stand an entity independent of the physical world, but rather functions as a primary, always open local doorway into a implicit knowing of universal consciousness. We can say that the paradigm of non-local realism automatically has a center of the mind of the observer. To put it somewhat different in terms of non-local realism, the observer becomes the center of the universe and holds for every observer. How is it possible for the center of the universe to be at different locations? Is it possible because each mind has a common foundation of implicit meaning embedded within the universal consciousness? This implicit field functions prior to any sense of difference, non-symmetry, and therefore the observer, while always a secondary feature to universal consciousness, will at the same time be the central locale for all potential and actual social exchanges. One of the important social consequences that flow from this is that all observers are equal in being at the center of the universe, with none left out. And many of the evidence is pointed out throughout the last 70 years of the non-local approach to reality. But even under the Copenhagen interpretation, some of the effects of non-local realism can be appreciated when we apply to Copenhagen interpretation. According to this interpretation, physical systems do not have a definitive differential or explicit property until measured by local minds. This is an accurate description of the function of the human mind. However, local minds do not exist on their own as assumed by local realism, but only exist within the context of non-local consciousness, which has a foundational role to play in all local measurements. In the vocabulary of quantum mechanics, the act of measurement affects the system, causing a set of probabilities to reduce to one after measurements. Measurement is defined in local realist terms as testing or manipulation of a physical system in order to yield numerical results. Bohr believed that the result measurement could only be described in the language of classical physics, that it made no sense to us what's going on in the invisible quantum realm. From the worldview of non-local realism, he is entirely correct. It makes no sense to try to describe distinction within the invisible, unmeasurable realm universal consciousness because there are no conscious distinctions within this domain. In this domain, there are only hidden relations, and the human uncertainty that always intend non-local implicit exchange. Another window into the dilemma of local reality is obtained from more minimalist interpretation of quantum determinism, given the statistical interpretation or a sample interpretation of quantum mechanics. Based by Max Born, the statistical interpretation distribute functions taken at face value. These functions used only to predict probability. The behavior of a sample particle can be predicted, but not the behavior of individual systems of particles. Comprehensive interpretation and statistical interpretation is just mathematics, to clarify. For scientists who employ non-local realism to organize their work, it will mean that all experiments take place within a non-local as well as a local world. In other words, every experiment in whatever discipline will have a classic, macro, local time and space options. Movements and measurements operate concurrently with non-local, unmeasurable interconnections of universal consciousness, which the scientist's mind will be a part. This integrated duality tells us that within every scientific experiment there are not two contradictory conceptual schemes at work, micro and macro, as many local realists assume. Rather, non-local realism takes account the encompassing singularity of universal consciousness, and the unifying reality involves a relation that are implicit and non-local as well as these are explicit, practical, and local. In other words, non-local realism embraces invisible, unmeasurable relations as well as those visible objects and forms associated with explicit and differential relations. Applying this to biology, the non-local realist will not refer to life when looking through the electron microscope at the structure of the bacterium. The integrated reference here should be a local life form. The general designated life property apply reference to animated field of universal consciousness because life is one of its characteristics. Plant neurobiology is a recently developed field of plant biology. Research aims at understanding how plants perceive their circumstances and respond to environment input in an integrated fashion. This field of research brings up the controversial question of plant intelligence, and the less controversial newly developed field of bioinformatics, which seeks to explain black communication, now well established as plant signaling. We will speculate that by applying a non-local approach to plant neurobiology, research and especially to the problems of plant communication, this exchange will be more productive than using the orthodox paradigm of local realism. One of the examples that would change will be the deletion of the term information from research and replace it with meaning. Information is a mechanical local realist term that separating theory of which tends to prevent deeper understanding of the implication inherent within any and all forms of communication. Hence, the communication is understood to indicate exchange of meaning that lengthen unities and integrate connection with the communication exchange between organisms of any kind will tend to become more obvious. These integrated aspect of plant communication should also assist with the controversial question of plant intelligence, because the slight line within such non-local observation inherently take account of consciousness, hence will not be inhibited by local realists' predisposition for division and separation. In other words, the controversy about plant intelligence is generated by the worldview of local realism, and so it does not come from any scientific evidence. The scientific investigation and interpretation framed by non-local realists will have a very different character to classic local realist ones. Under the influence of non-local realism, the universe is no longer a dead, insensate world, but rather an animate participatory universe, where every single physical object, from particle to galaxy, from microscope to monkeys, will contain more hidden connection, meaning than what is revealed by the appearance of their physical shape, exchange, and movement. Finally, an example of non-local realism comes from the philosopher Otto Young, who stated that photons have no mass, charge, or time, which suggests their behavior transcends physics in the manner that consciousness does. And what I mean by that, it's not something beyond the physical, spatial, temporal world like the supernatural. It's just beyond the current understanding that is still within the physical space-time. Young also wrote that light is not like other things, and light is not seen as a seen. When light comes as seen, there are no more dualism of subjective seer and objective seen, rather it is simply a process within a singularity or interconnected universe that jointly involves a local mind along with non-local consciousness. What is given in this participatory process is the sight within seeing that is seeing access of visual perception, yet the ownership of that sight does not come from separate local mind or the intention of an individual who has almost no control over seeing or not seeing. Rather, the ownership and agency of the sight within our seeing entirely rests with non-local universal consciousness. In conclusion, The non-local realism suggests the usefulness of local realism as a world is severely limited, and science in the future will most likely turn to an inclusive, integrated paradigm of what we call non-local realism. And like I said about the Nobel Prize, I want to talk about that real quick about the experiment. Written by Daniel Carterson in the Scientific American. In quantum physics, the universe is not locally real, and the physics Nobel Prize winners prove it. Elegant experiment with entangled light have laid been profound mystery at the hard reality. One of the more outstanding discoveries in the past half century is the universe is not locally real. Real meaning that objects have definitive properties independent of observation. An apple can be read even when no one is looking. Local means objects can only be influenced by their surroundings, and that any influence cannot travel faster than light. Investigations in the frontier of quantum mechanics have found that these things cannot be both true. Instead, evidence shows objects are not influenced solely by their surroundings, and they may also lack definitive properties prior to measurement. Einstein famously said to a friend, "Do you really believe the moon is not there when you're not looking at it?" This is, of course, deeply contrary to our everyday experience. The phrase by Douglas Adams, "demise of local realism," has made a lot of people very angry and be widely regarded as a bad move. Blame for this achievement is now being laid squarely on the shoulders of three physicists, John Clauser, Elliot Aspect, and Anton Seeliger. They equally split the 2022 Nobel Prize in Physics for experimenting with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science. So basically, quantum internet, basically Star Trek style technology. Yay, we gotta witness that. The colleagues agreed that the trio having come to serve this ranking for overthrowing reality as we know it is a fantastic news. He is a long overdue, says Sanu Prosper, who is a quantum physicist. The experiment began with the earliest one of cluster and continuing along showed that this stuff isn't just philosophical, it's real, and like other real things, potentially useful. Each year I thought, or maybe this is the year that says Dr. Kaiser, physicist and historian at the Massachusetts, MIT, that this year it is very emotional and very thrilling. Quantum Foundation journey from French to favor was a long one. From 1940 until as late as 1990, the topic was often treated as philosophy at best and crap pottery at worst. Today, quantum information science is among the most vibrant and impactful subfields in all of physics. It links Einstein's general relativity with quantum mechanics via still mysterious behavior of black holes, integrate design and function quantum sensors, which are increasingly being used to study everything from earthquakes to dark matter. It clarifies the often confused nature of quantum entanglement, a phenomenon that is pivotal to modern material science that lies at the heart of quantum computing. What even makes a quantum computer quantum? One of the most popular answers is entanglement, and the main reason why we understood entanglement is the grand work participated in by Bell and these Nobel Prize winners. Without that understanding of entanglement, we probably should be able to realize quantum computers. The trouble with quantum mechanics was never that it made the wrong prediction. In fact, the theory described the microscopic world splendidly well right from the start when physicists devised the opening decades of the 20th century. And give me a second, I was about to sneeze. But under quantum mechanics, particles are not like socks, and only when measured do they settle in a spin up or down. This is the EPR paradox key conundrum. If Alice's particle lacks a spin until measurement, how then when they whiz past Neptune, do they know Bob's particle would do if they fly the solar system in other direction? Each time Alice measured the aesthetically quizzes her particle, the Bob will give it flip a coin up or down. They also correctly prediction this even 200 times in a row, or 1 in 10 of the power of 60, a number greater than all atoms in the solar system. Yet despite the billions of kilometers that separate the particle pair, quantum mechanics says Alice's particle can be correctly predicted as though they were telepathically connected to Bob's particles. Although intention to reveal the imperfection of quantum mechanics when real-world versions of the EPR for experiment are conducted, the result instead reinforced the theory's most mind-boggling tenet. Under quantum mechanics, the universe is not locally real. Particles lack properties such as spin up or spin down prior to measurement and simply talk to one another no matter the distance. Physicists skeptical of quantum mechanics proposed that there was a hidden variable. factor that exists in some imperceptible level of reality beneath the subatomic realm that contain information about the particle's future state. They hope in hidden variables theory, nature could recover the local realism denied to it by quantum mechanics. One would thought the argument of Einstein, Podolsky, and Rosen would produce a revolution at the moment. Everybody would have started working in hidden variables. Quantum mechanics problem non-local realism will languish in commonplace stubborn, and another 3 decades about being decisively shattered by Bell. From the start of his career, Bell was bothered by quantum orthodoxy and sympathetic toward hidden variable theory. Inspired struck him in 1952 when he learned the variable non-local hidden variables interpretation of quantum mechanics, devised by David Bohm. Sometime von Neumann had claimed was impossible. Bell molded the idea over the years as a side project that his main job work as a particle physicist at CERN. And this is more of a history takedown about Bern and going straight to the stats. One great final loop remained to be close or at least narrow any prior physical connection between components, no matter how distant in the past, has a possibility of interfering with the validity of Bell's test results. If Alice shakes Bell's hand prior to departure on a spaceship, they share a past. It is seemingly implausible that local hidden variable theory would exploit these loopholes, but still possible. In 2017, a team including Kaiser and Siliger before a cosmic Bell test using telescopes in the Canary Islands. The team's sources ran the decision to detect a satellite from stars sufficiently far apart in the sky that light from one would not reach the other for hundreds of years, ensuring a century-spanning gap in their search cosmic paths. Yet even then, quantum mechanics again proved triumphant. One of the principal difficulties in explaining the importance of Bell's test to the public, as well as the skeptical physicists, is the perception that the veracity of quantum mechanics was a foregone conclusion. After all, researchers measured many key aspects of quantum mechanics to a precision greater than 10 parts in a billion. I actually didn't want to work on it. I thought, come on, this is old physics. We all know that's going to happen. Gistunia says, but the accuracy of quantum mechanics could not rule out the possibility of local hidden variable. Only Bell's test could do that. What drew each of these Nobel recipients to the topic and what drew John Bell himself to the topic was indeed the question, can the world work that way? Kaiser says, how do we know with confidence? What Bell test allows physicists to do is remove the bias of anthropocentric aesthetic judgment from the equation, purging from their work other parts of the human cognition that recoil the possibility of inexplicable entanglement, or that scoff and hidden variable just as more debates of how many angels have danced on the head of the pin. The award honor cluster aspect of Siliger that this is a statement all the researchers who were unsatisfied with the superficial explanation about quantum mechanics, and who asked their question even doing so was unpopular. Bell's tests, Guston conclude, are a very useful way of looking at reality. And like I said, this is a change our way how we view reality. And like I said, all the previous scientific or sometimes these religious not just promoted that we were skeptical, critical, if not rejected outright, now we have to reconsider. This does not mean the supernatural exists. It just means that they may be right or maybe onto something. They just falsely assumed that it was a supernatural phenomenon, right? And the same thing, like people were critical about magnetism. Does it shape the universe? For the longest time, people thought it was no, that's stupid, right? But the experiment had proved that involving plasma that is already probably to show that. How do I say that? In the article New Scientist, the magnetism shaped the universe. An epic experiment suggests it did. There are few places on Earth where conditions get as extreme as they do. At the National Ignition Facility near Los Angeles, at its heart, 192 lasers are trained in a gold cylinder roughly the size of a AA battery. As the beam covers, the temperature at the test chamber leads to 100 million OC, hotter than the center of the sun. The facility was built to investigate the possibility of harnessing nuclear energy, which promised unlimited clean energy. But earlier this year, researchers announced that a powerful laser also been directed at the different kind of big question: what shaped the universe? And basically magnetism, so magneto. But going back, like I said, with the new discovery of the universe functions non locally, and the Nobel Prize, right? the winners were fundamental contributions to the works of quantum mechanics, which involve experiment using entanglement or connected particles of light called photons. The experiment showed that information could be instantly transmitted over infinite distances, known as quantum teleportation. This essentially showed the measure where the quantum mechanics is like a billboard model of Newtonian mechanics, where one thing must follow another at a local scale, or where the particles separated by amount of space can affect each other. Pell's proposal involved measuring the property of two entangled particles in a system isolated from anything else that could influence the result. Such observation inversely affecting the entangled partner through measurement to see if they exceed a certain value, creating a mathematical inequality, provide the local effects alone can explain quantum mechanics. So, en 1989, colleagues expanded Paul's inequality beyond just two entangled particle to state of three or more entangled particle called a GHZ state. This is form a key indicator for many quantum technologies, including quantum computers, que they make quantum bits or qubits. We want to go back in order to people lay the groundwork for this to become quantum science. And also, from an anarchist perspective, this also showed that nature has an anarchist bias, basically. From the website Anarchy in Action, which is pretty old at this point. This is like from the last thing they updated was like 2016, 17. So, regardless, some anarchists found inspiration in finding a post-Newtonian physics that suggests the universe may be much more self-organized, spontaneous, and interconnected than Newton's physics suggests. The theory of general relativity can be seen as a blow to Newtonian worldview of a dead mechanistic universe that, as science historian Carlo Merchant has pointed out, helped capitalists rationalize the exploitation and colonization of nature. Scientists have found self-organization in supposedly inanimate world where, from cloud formation to formation of galaxies, the unpredictability of quantum mechanics arguably provides a better grounding for free will than predictable quantum mechanics did. And theories of the multiverse offer a non-theistic explanation why our solar system universe are so conveniently suited for life without making resource to any creator dominating over the cosmos. Chaos theory has caught the attention of anarchist interest in the universe spontaneously and unpredictability. Such findings and theories in modern physics provide compelling metaphor, at least for those interested in mutual aid, sustainability, and horizontal society. As physicist Nick Herbert explains, in the Middle Ages, where virtually everyone believed the world to be a personal creation of divine beings, society mirrored the hierarchy that supposedly exists in the heavens. Dante's picture of the world gave everything and everyone his proper place in the medieval scheme of things, coinciding with the rise of Newtonian physics as a central to modern democracy which stressed a rule of laws rather than man. A Declaration of Independence, for example, we hold this truth to be self-evident, reads more like a mathematical theorem than a political document. And to show you examples of this, we had to go like again quantum mechanics. And to show that in 1900, Max Planck argued that light and other electromagnetic wave consists of packets called quanta, and branch of physics called quantum mechanics emerge, which describe what occurs at the smallest scale of the universe. One of the most startling aspects of quantum mechanics is Werner Heisenberg's uncertainty principle, which said that the position and the velocity of a quantum-scale particle prior to its measurement can never be determined. Heisenberg noted that in order to measure the speed or velocity of any particle, you need to shine a light on it. If you shine a light with a high wavelength, you can measure the particle's velocity, but you can't measure its precise location. To find the precise precision, you need to use light with a short wavelength. The problem is that when you shoot light at the particle, the light affects the particle's velocity. The shorter the wavelength, the more the light affects the particle's velocity. So the more accurate you measure the particle's position, the less accurate you can measure what its velocity was. The uncertainty principle showed that scientists cannot predict with certainty the movements of particles. Stephen Hawking writes, one of the revolutionary properties of quantum mechanics is it does not predict a single definite result for observation. Indeed, it predicts a number of possible outcomes to test how likely each of these is. It may be tempting to think that the particle actually has a definite position and velocity all along, and the measurement really disturbs the particle, which had definite state prior to measurement. Nick Herbert called this view a disturbance model. However, phenomena such as quantum entanglement contradicts the disturbance model. The position and velocity of objects are actually probabilistic, in a way that has required scientists to explore new conceptions of reality. And in path integral formation, one of the consequences of this uncertainty principle is the concept of particle-wave duality. The tiniest bit of matter behaves both like a particle and like a wave. Fire electrons normally flew off as particles at wall with two slits, and the electrons would interfere each other as if they were wave of light. The screen on the other side of the wall will show patterns that look like wave was sent through the two slits. Remarkably, the same result occurs to the electron of fire one at a time. Hawken and Modonino explain each electron therefore must be passing through both slits at the same time and interfering with itself. But in quantum entanglement, two quantum objects can be entangled in such a way that one spins in one direction and the other instantly spins in the opposite direction. If the Einstein and others at the time argue against quantum mechanics, saying that if the two particles were entangled, then just in opposite direction and distance, one would have to be able to somehow send information of the other faster than the speed of light. Einstein ridiculed this communication as impossible, spooky action at a distance. With Bell's theorem, physicists calculate that if quantum mechanics were correct, if the two particles could be correlated in one way, while if Einstein and the other skeptics were correct, the article would be correlated the other way. Experimentation with entanglement particles proved quantum mechanics correct and Einstein wrong. The entanglement of particles across the universe implies a much stronger interconnectedness across galaxies than Newtonian physics envisioned. As Antonio Kaku writes, there is a cosmic entanglement between every atom or body and atoms that are light years distant. Since all matter came from a single explosion, the Big Bang, in some sense the atoms of our body are linked with some atoms on the other side of the universe into some kind of cosmic quantum web. Entangled particles somehow like twins still joined by an umbilical cord, their wave function, which can be light years across. What happens to one member automatically affects the other, and has knowledge concerning one particle instantly reveal knowledge about this pair. Entangled pair as if they were a single object, although they may be separated by a large distance. More surprisingly, since we have function of the particle in the Big Bang were once connected and coherent, their wave function will still be partially connected billions of years after the Big Bang, so that disturbance in one part of the wave function can influence another distant part of the wave function. According to Nick Bird, Bell's theorem showed that holistic grammar or quantum formalism reflect the inseparability nature of reality itself. Beneath phenomena, the world is a seamless whole. Herbert concludes, religion assures us that we are all brothers and sisters, children of the same deity. Biologists say that we are interweaved with all life forms of this planet. Our fortune rise or fall with theirs. Now physicists have discovered that every atom or body are woven out of the superluminous fabric. More consciously, Richard Hiley, in the Standard Encyclopedia of Philosophy, writes, superficially, such entanglement of systems already demonstrate non-separability. At the deepest level, it has been maintained that the positive statistics that arise from measurement on entangled quantum systems either demonstrate or explicit in terms of holism or non-separability, rather than any problematic action at a distance. I will put the article of holism and non-separability in quantum mechanics in the Stanford Encyclopedia of Philosophy. The many interpretations of quantum mechanics, like Scortioner's cat, with thought experiment illustrate a number of ways that quantum physicists understand reality. Suppose that inside a pot there is a cat. If you're already familiar with this, how quantum mechanics. According to this interpretation, quite prior to measurement, cat exists in a quantum state or wave function, which is both alive and dead at the same time. And now we know it's not instantaneous, and recently it's like 0.16 trillion of a second is where the smallest measurement can happen. But Rachel Wiking warns is not take the experiment literally at the face value, as can lead to some extreme misconception about quantum mechanics. At best, the superposition can be represent our certainty and our lack of knowledge about the state of the cat. So the death and the life interpretation is true only on a metaphysical and probabilistic level. To mistake it as a physical reality for the cat is an entirely different matter. The article goes on to point that the cat itself, or even Georgia account, can be interpreted as an observer that collapsed the quantum state well before scientists opened the books. Now, in the many worlds interpretation, said the cat is both dead and alive because the universe has split into two. In one universe, the cat is dead; in another universe, the cat is alive. In fact, at each quantum juncture, the universe splits in half, a never-ending sequence of splitting universes. It described the splitting world during a variation screwdriver thought experiment. As in the Everett FAQ, The cat is placed in a sealed box with a device that releases a lethal dose of cyanide if a certain radioactive decay is detected. According to many worlds, the device was split into two states, the cyanide release or not. But the radioactive decay, which is thermodynamically irreversible process, as the cyanide slash no cyanide interacts with the cat is split into two states, dead or alive. The investigators split when they open the box. The advantage of the many worlds interpretation is that it does not require wave function to collapse, making it simpler than competing theories like the Copernican interpretation. Although Bayes' theorem does not apply to many worlds interpretation, every world will still imply an interconnectedness of things across the universe. As Nick Herbert elaborates, any model of reality which a tiny event on the Andromeda galaxy can instantly split my reality into thousands of zero copies cannot by any stretch of the imagination be called local. The Everett worldview has some poetic affinities with the Zapatista's concept of a world where many worlds fit, and the alter globalization slogan, another world is possible. It also allows for the anthropic principle to explain plausibly how the universe develops specific conditions for life without divine intervention. But in the Copernican interpretation says there is no deep reality prior to measurement, and there is an act of measurement collapse. The wave function of an object into a definitive state is a measurement then to make the cat either dead or alive. Nerman explained the implication. We now know the moon is not there when nobody looks. In 1975, do not take this book seriously. There is basically pseudoscience. It's just more poetic metaphors than actual science. The book The Tao of Physics by Fridoji Capra used the Copernican interpretation to argue everything in the universe is connected. The core of his argument rests on the uncertainty principle, says no one can exist in a non-quantum state without being observed. Capra argues no object can be understood in isolation from other the observer. But his book is controversial among scientists, as the website Rational Wiki gives out. Many who acknowledge Kappa describe quantum physics fairly through its correlation between it and Buddhist mysticism were superficially and silly, and Peter Wood noted that book used quite a bit of out-of-date physics. Physicist John Gripen described the Tao of Physics as the only period of quantum-based mysticism that had any genuine grasp of quantum physics at all, although the book's physics has been sincerely criticized by Victor Stern, who made multiple books. He's from the New Atheist movement, and I made a book about the quantum gods and debugging many of the pseudoscience of quantum mechanics, stuff like that. And like I said, even though he was critical, rejected quantum consciousness because he assumed the universe functions under local realism. Now we have to revalue this. According to Capra, the physicist Stephen Weinberg argued that Copernican does not preclude the deterministic view of the universe, even though the position velocity of the particle cannot be known. Weinberg writes that wave function can be known by repeatedly measured many times for the same initial state. If you can work out what the wave function in the state must be, use the result to check out your theories. Any system is a definitive state whether any human observer in it or not. The state is not described by a position or momentum but a wave of function. However, many quantum physicists appear to share Capra's commitment to the methodology that recognize the impossibility of reducing the universe into separate definitive objects. Hawking and McDonald share Capra's belief that it is impossible to understand any object without understanding how the observer interacts with it and affect it. They explain, according to quantum physics, you cannot just observe something. That is, quantum physics recognizes that to make an observation, you must interact with the object you observe. In David Byrne's interpretation of quantum mechanics, the offering alternative to both many worlds and Copernican interpretation, he believed that the universe is an undivided whole. He wrote, one is led to a new notion of unbroken wholeness, which denied the classical analyzability of the world into separate and independent existing parts. The inseparable quantum interconnectedness of the whole universe is the fundamental reality. Now, in the string theory and M theory, while relativity theory describes phenomena on a large scale, quantum mechanics on a small scale, neither theory can completely explain the universe. Especially gravity does not conform to quantum mechanics. Scientific research for quantum theory of gravity that combines the insight of relativity and quantum mechanics. String theory, invented in 1960, tends to provide a unifying theory of physics, suggests that particles are actually vibration strings that occur up into 26 dimensions, which never notice the extra dimension beyond the four we inhabit: length, width, length, and time. Since they are curled up into million of an inch. The 1990s, some physicists decided string theory all belonged to a more fundamental theory called M theory, which Stephen Hawking writes is only candidate for a complete theory of universes. A consequence of there being many universes today becomes much more explicable that our solar system, one of many galaxies and many universes, has the very unlikely combination of physical conditions for light to develop. As with the many worlds interpretation, N theory has an implication of a non-local connectedness, where the observer of one end of the universe can spark formation of the modified replica of the entire universe. Finally, the existence of further dimensions allow for a possible connectedness unnoticed in the first four dimensions. If these additional dimensions are appropriately considered spatial, then processing involving classical spring will count as spatial-temporally non-separable, even though all particles and their properties conform to spatial separability. And like I said about the panpsychism that Sinclair accidentally promoted, even though he is against it, the late David Graeber found a basis for the philosophical notion of panpsychism. He argued that all matter has at least some basic level of consciousness. As a possible evidence for panpsychism, David Graeber cited the self-organization, spontaneity, electromagnetic fields, snowflakes, and subparticles. In the article he wrote, Why We Cannot Have Fun, or more to the point, why are perfectly willing to ascribe agency to a strand of DNA, however metaphorically, but consider it absurd to do the same with electron and snowflake or a Korea electromagnetic field? The answer seems because it's pretty much impossible to ascribe self-interest to a snowflake. We have convinced ourselves that rational explanation of action can consist only in friendly action as there was some sort of self-serving calculation behind it. Then, by definition, all of these levels, rational explanation can be found. Unlike the DNA molecule, which can at least pretend it pursues some gangster-like project of ruthless self-aggrandizing, an electron simply does not have a material interest to pursue, not even survival. It is no sense competing with other electrons if an electron is acting freely. If Richard Feynman is supposed to have said does anything he likes, it can only be acting freely as an end of itself, which will mean that in the very foundation of physical reality, we encounter freedom for its own sakes. We also mean we encounter the most rudimentary form of play. And I think that's it for now. This is a very interesting way to understand that this changed everything, and we had to revalidate all the previous ideas that we were critical, if not rejected. Now the universe we know functions non-locally, and Einstein was basically fundamentally wrong. Let's see what new evidence and discoveries we find. I hope to see you guys next time.